Hello class 9 students. So now we are in a new chapter and the name of the chapter is Gravitations. It is chapter 3 from your textbook. On this chapter we will study the Newton's gravitational laws and Kepler's laws and many and so on. So first of all, let us understand what is gravitation, gravity. We have experienced that why apple fall down from the tree, why we are standing on earth, any object is falling down from some height. Why it is falling down? We know that it is because of the gravity. So what is that gravity actually? It is the attraction between two masses. Okay, between two masses, the attraction each other between two masses. And it was been discovered by Johannes Kepler and Isaac Newton. So it was first observed by Kepler in 1571 till 1630, and later Isaac Newton modified and studied about gravitation on the year of 1643 to 1727. So this gravitation is not new on us. It was discovered for a long time. Okay. See, you might have imagined why the stars, why the planets move around the suns, why the stars is not keep on falling on one object to another. Because of this gravitation, there's a force of gravitation, or we can say as the attraction between them that makes them revolve around its own orbits. So let us see in the next slide what is gravitation or gravity. Gravitational force of the earth or gravity. A force is necessary to produce motion in a body. So we know that in that chapter 2, that is force and law of motion, we already studied that what is a force, and we know that the simple is that it's a push or pull. Okay, it's a push or pull to change the direction of motion, or we can do many things else. That is a force. So same thing here, force is necessary to produce motion of a body. Okay, a body drop from a height fall toward the earth. Suppose any body, any object is dropped from the height, from a long height towards the earth. It indicates that the earth exerts a force of attraction called gravity on the body. So that means that there's a gravitation, or we say as a gravity of the earth to pull that object towards the earth. Okay, just like the apple is falling down from the tree, and it reached where? It reached the land, it reached the earth. In fact, the earth attracts all the objects toward its center. So you have to remember that this is the fact that the earth attracts all the objects toward its center. Center of the earth, there's a core. The force with which the earth pulls the object toward it is called the gravitational force of the earth or gravity. So here is the definition. You can write this one, or you just memorize from here that what is the gravitational force of the earth or gravity? Is the force with which the earth pulls the object towards it is, or toward itself, is called gravity or gravitational force. Okay. The gravitational force between the sun and the earth keep the earth in the uniform circular motion around the sun. So, for example, the earth is removed around the sun. It removes around the sun one revolution, that is 1 year, in 365 days. So, what makes them to move around the sun? Uniform constantly. This is because of the gravitation force. And you see here that the gravitation force of the sun and the earth keep the earth revolve uniform circular motion around the sun. Okay. So now let us see the gravitationals of the earth, or gravity is responsible. So first, for holding the atmosphere above the earth. So there's an atmosphere above the earth. Mesosphere, stratosphere. There are so many layers in the atmosphere, and it holds those atmosphere above the earth. Without gravity, those atmosphere will not be there. It will go away. Okay, that is our importance or the responsibilities of the gravitational force, or we say gravity. Number 2, for the rain falling to the earth. So the rain is falling to the earth. It's not going left or right, it's falling upside down to the earth. Water is floating on the river. So even the water is flowing in the river, it's not floating in the air, but on the river, on the land. So why? Because of the gravity. For keeping us familiar on earth. So we can walk, we can jump, we can do anything on this earth because of the gravity. Not like in the moon or in the space where there's no gravity, we will float on there. For the revolution of moons around the earth. So even the moon revolves around the earth because of the gravitation. We say the gravity of the moon and the earth. So there are the responsibilities of the gravitation, or we can say gravity. Let us see Newton's universal law of gravitation. What did Newton talk about gravitation? It is here. He said that every body in the universe attracts every other bodies with a force which is directly proportional to the product of their masses and is inversely proportional to the square of the distance between them. So what does that mean? He said that the force that is every body on the universe have that force, and that force is directly proportional to the masses, the product of the masses, and inversely proportional to the square of the distance between them. So he said that any two masses, any two objects, they will have their own masses and they will have that force of attraction, and that force is nothing, is just the product of their masses and divided by the square of the distance between them. So let us see this derivation to understand. So let us take two bodies A and B, as we see here in the figure, and having the mass m1 and m2. And we don't know which one is bigger, which one is smaller. We just say m1 and m2 are placed at the distance of r from each other. So the distance between them, it is r. So let F be the force of attraction between two bodies. Then what is said? The force of attraction is directly proportional to the product of the masses. So F is directly proportional to the product of masses. You see this sign? This sign is a sign of proportionals, and proportional means like almost the same, but it's not exactly. Okay, proportional means almost the same, but not exactly. So force is directly proportional to the masses, m1 multiply m2. And he also said that the force of attraction is inversely proportional, means upside down, almost the same, the square of the distance between them, and 1 by r. R is a distance and square of the distance. Okay, so what we get now, joining these two, we will get the force. You will get the force. It is F is directly proportional to m1 multiply m2 divided by r square. And we know that this sign proportional we have to remove. By removing this sign proportional, since we know that it is not the same, it is almost the same. So how to remove this one? By putting a constant. By putting any constant, we can remove the sign of proportional. So here, they remove the sign of proportional and they put equal and they replace by G. And G is the universal gravitational constant. It's very important. G is what? G is a universal gravitational constant. That is a capital G. And now we will get the formula of the force. And from here we can calculate the force between two masses of any body by using the universal gravitational force, universal gravitational constant, the masses of the two bodies and the distance between them. And we will know the force, how much is the force of attraction between the two bodies. Okay, now let us see the properties of gravitational force. First, let us see the gravitational force is the weakest force in nature. So it is the weakest force in nature. Remember that. Number 2, it is attractive force. Unlike electrostatic and magnetic force, they are both attractive and repulsive. So in electrostatic, they will have attractive at the same time, and unlike poles, they are repulsed, means they are repelled, but not like in the gravitational force. Gravitational only have attraction but no repulsion. Remember that. Number 3, it is a mutual force. That means that the first body attract the second body and the second body attract the first body with equal force. So each other they attract each other, the first body and second body, and they attract with the same force. That's why it is a mutual force. It is a central force. So remember that it is a central force. It acts along the line joining the center of the bodies. So remember, it is a central force. That's why it acts on the center of the body. So let me try to show you here how. Suppose this is a body. I will try to make this red pen. This is a body, a mass of any body. So this force is act on the center, not from here, not from here, but from here at the center. At the center, okay? It will act at the center, and another body at the center. Understood? Just like that. Number 5, it is the mass and the distance dependent. So it depends on the mass and the distance between them. Number 6, it obeys the inverse square law. So it is inversely proportional to the square of the distance. So it is obey the inverse square law. Number 7, it is a long range force. So it is a long range force. So that's why we need to, by using this formula, by using this Newton gravitation, we can find the force of attraction between the earth and the moon. So it's a long range force. So it decreases with the distance as per inverse square law and becomes zero only at infinity distance, like electrostatic and magnetic force. Number 8, it does not depend on the medium. between the interacting bodies. That means that there is no gravitational shielding, so there is no medium required on the gravitation. It is same even in the space or a vacuum, or even in any medium. It does not depend. Okay, even in water, even in air, even in space, it doesn't depend on any medium. Okay, now let us study what is that G, that is the universal gravitational constant. This is a constant made by Newtons. So this constants have a formula. Using that Newton's universal law, you get F equal to G m1 m2 by r square. And replacing the G, you can find it is like this. And we now will find the value of G. So the value of the universal gravitational constant G is 6.67 into 10 to the power minus 11 Newton meter square per kg square. So that is the value of a capital G, universal gravitational constants. You have to remember this by heart. Okay, you will need this one in calculation. So look here, the value of G does not depend on the medium between two bodies. So keep that in mind. It's not depend on any medium. It will always the same because it is constant in any medium. The value of G is the same throughout the universe, and hence the name. So it is the same. The value of G is always the same. The whole universe is always the same. Newton said that. The universal gravitational constant G is different from acceleration due to gravity. So there is a G capital and a small g capital, and there's a difference between them. The small g, the value of a small g, that is acceleration due to gravity, is 9.8 meter per second. Okay, so therefore correctly symbols must be used accordingly. The SI unit of G is Newton meter square per kg square. If two bodies of a mass of 1 kg each are separate by 1 meter from each other, then G equal to F. So remember that if two bodies of the mass 1 kg and it is separated by 1 meter, then the universal gravitational constant is equal to the force. This G equal to F. Therefore, universal gravitational constant G is a numerical equal to the force of gravitation which exists between two bodies of the unit masses keep at a unit distance from each other. Okay. So here we have to know that the gravitational force is the weakest force of all, and the value of G is 6.67 10 to the power minus 11 newtons, where the two masses are 1 kg and separated by 1 meter. So we know that through the various objects of the earth attract one another constantly, they do not cause any visible motion because the gravitational force of attraction between them is very, very small. So let us imagine a situation on the earth if the object continuously move towards each other due to gravitational force between them. And what happens? When both of the objects are very big, having very large masses, then the gravitational force of attraction between them become extremely large. The gravitational force due to gravity on the object of a mass 1 kg placed on the ground is 9.8 newtons. Okay. Another is that the gravitational force between the Earth and the Moon at even the largest distance is very large, and it is 2 into 10 to the power 20 newtons. So this is the gravitational force between the Earth and the Moon. So remember that this one, it will come in MCQ. Only this one. Thank you, class.